All right, so today we're going to talk about literal equations. So solving a literal equation is just like solving a regular equation. It's just we typically have more variables and less numbers. We might have a mixture of both. We might have some numbers and some variables. But when we're solving, we're just going to isolate the given variable. So whatever variable it asks us to solve for, that's what we're trying to isolate. All right, so example 1, we're going to solve d equals rt, and we have to solve for t. All right, so our goal is to isolate the given variable. Now, our given variable is what it's asking us to solve. So the given variable in this problem is t. So we're solving for t. That's my given variable. And we're going to do that by using inverse operations. Now remember, an inverse operation is the opposite operation. So for example, the opposite of multiplication is division, and vice versa. The opposite of division is multiplication. Then the opposite of addition is subtraction, and the opposite of subtraction is addition. Okay? All right, so we first, in order to isolate our variable, we're going to divide both sides by r. Because if we take a look at r is being multiplied by t. So t is what I want to solve for. That's what I'm trying to get by itself. So in order to get it by itself, I'm going to undo the multiplication, and we're going to divide both sides by r. Okay, so where my t is, remember, anything divided by itself makes 1. So the r divided by itself is going to make 1, leaving t by itself. So t is equal to d divided by r. So you can rewrite that as t equals d divided by r, and that's our answer. All right, so example 2. So we have p equals 2 times L. That's how I write my L's, because I don't want you to mistake an L for a 1, plus 2W, and we're going to solve for W. Okay, real quick. So another thing I want you guys to remember is that when we're using opposite operations or inverse operations, we're actually going to end up using PEMDAS backwards. So you can either just write it out backwards, or some people like to call it SAD MEEP. It sounds funny, but we're still using the same things that it's for. So the S and the A, remember, it's subtraction or addition, whichever comes first from left to right. All right, and then we have the division or multiplication. And that's the same thing, whichever comes first from left to right. And then we check for exponents. And lastly, we would check for parentheses. All right, so now let's look back at our problem. So I'm going to start with S or A, see if there's any subtraction or addition that I can do to try to isolate my variable. So yeah, the W is being multiplied by 2, but it's also being added by 2L. So I'm going to do the opposite of adding 2L, and I'm going to subtract. All right, so then we get P minus 2L on the left equals 2W. So if we look at what I'm trying to solve for, the W, it's still not by itself yet. So let's keep moving on down the line. So in SAD MEEP, I did subtraction or addition, so now let's look at division or multiplication. Well, W is being multiplied by 2, so I'm going to do the opposite, which is divide. So I have to divide everything by 2. I can't just divide one term, I have to divide both terms by 2. So 2 over 2 makes 1. So I get P minus 2L over 2 equals W. And that's our answer. And then you can rewrite it if you want the variable on the left. So W equals P minus 2L divided by 2. And that's it. All right, example 3. So we're going to solve x divided by 3 plus 12y equals 2, and we're going to solve for x. So I'm still going to check and use SED-MEE, but we're going to work backwards. So I'm going to check for subtraction or addition if I can move any subtraction or addition over first. So we're solving for x. Well, x is being divided by 3, and it's being added by 12y. So yes, I'm going to subtract first. All right, so we're going to subtract both sides of my equation by 12y. So we get x divided by 3 equals 2 minus 12y. All right, so x isn't by itself yet. X is being divided by 3. So to undo the division, I'm going to multiply both sides by 3. All right, so when I multiply these, I can put that over 1. These 3's are going to cancel out on the left, so I'm just left with x on the left-hand side. But I have to multiply the right-hand side also by 3. What we want to do is I'm going to put parentheses around the whole thing, and then we're going to multiply by 3. Now, when we have parentheses, I have to distribute, because this is going to make sure that I'm multiplying this 3 to both terms on the right-hand side. So we end up getting x equals 6 minus 36y. And that's it. That's what x is equal to. So we've just solved literal equations.